This is Team Awesome, and we are doing our project presentation for Milestone 4. I am Eric Look.
This is Brian Bennett.
This is Clay Vermella.
Our project involved a restaurant called Gill's Supper Club, and originally what we designed it for was to to create a reservation system, and also to keep track of inventory, and it was going to replace the existing reservation system that entailed a lot of overhead with the employees there. And instead of having to write down reservations where we took the customer's phone number and their last name, we thought that it would be of benefit to the business to create a database system which would allow the customer's information, such as their first and last name, their phone number, to be inserted into the database to have that keep track of the reservations. Now, what it ended up becoming of our original project design was very broad. It dealt with customers, we had employees, reservations, we had orders, we had the sections in the restaurant, and in each section we had multiple tables, and we even had other items such as the reports for like sales reports, inventory reports, schedules, scheduled hours for all the employees. We had to funnel it down to a much smaller scale so that we were able to implement it all in time and make it work efficiently in the way that we originally wanted the design to be. So what we ended up with was 9 tables, and this is the table creation spool from those. So as you can see here, we first drop all the tables in the opposite order of creation. Here we have our customer table with all the necessary information for each customer, including the customer phone number, which is the unique identifier. Now we're inserting data into here, and next we create the menu table. The menu table has a menu ID, which is the unique identifier for the menu table. Insert, I believe we have 9 different menu IDs here for different items such as entrees, side dishes, appetizers, desserts, sandwiches, salads, other. We have our item table with the item ID as a unique identifier for this, and we insert some items here. We have quite a few actually. These were all pulled from the actual menu of Gill's Supper Club to reflect the most accurate prices and names and descriptions that we could come up with. After we get through all of this, we come to our order table here. Now the order table has the customer phone number as a foreign key here, so that we're able to connect a customer to a specific order. And we also insert some trial data into these as well, including how many items they ordered, what the order number was, what day did they order this on, and also what is the cost of their entire order. And here we have item order, which references order ID and item, or order ID from the orders table and item ID from the item table. And this was our associative entity for order and item. And we have some data inserted into there. Come to our employee table. They're uniquely identified with the primary key of their employee ID. And we created a few employees here. And here we go to the table reservation, which uses the customer phone number from the customer table is as a foreign key, and we have several identifiers in here, such as the date of the reservation, what time they want the reservation, and also the party size, which is also, it's not allowed to be null because we need to know how big the party is so that we can check with the constraint to make sure that we can actually seat them for the date and the time that they want. And we create some reservations here with varying numbers of people and also the date and the time. And then we come to our last table, schedule, which we use to schedule employee hours, and also we use this later on to determine which employees we're going to need during certain dates and times, so that we're positive that we're able to cover the reservation needs for a certain date and time here. And I guess we have one more table. Menu item. This was our associative entity with item and menu ID, or item and menu, and we have data in there. And come around to all that. There's a lot to enter here as well. Okay. Here, after we created all the tables and inserted all the data, we went in and added the indexes that we needed for each table, just in places that we thought we would need an additional index besides the primary keys, such as the last name for the customer. Another good one would have been the customer phone number as an index on the orders. Also, the order date for orders was a good one, and employee. Besides the employee ID, we added an index for last name. And now we will go to the ERD.
As you can see from what Eric said, we have a fairly large database. So here's our ERD. Our initial ERD was fairly large in scope. It included such entities as inventory, jobs, tables, and sections. But we've compressed that down into a compressed ERD table. So notice that here, employees have a weak relationship between order and reservation. Each employee has its own schedule, which allows scheduling for each employee, and each customer is related to a reservation and an order. And then from order, we have item order here, which is related to item, and menu item, and menu, which has each items for each menu.
Alright, we'll now be going over to the queries. Here's our spool from our queries that we ran. We selected the best 6 that we felt fit our business needs. The first query we have here is displaying the total time worked for employees on a specific date. This allows us to see, to check payroll essentially, which would be a necessary view and function of the manager and owner. We have 3 executions for each query, 3 tests. The first one is for May 5th, the second one is June 5th, the third one is January 5th. As you can see, they all have different outputs. The next query displays a customer's first name, last name, phone number, date of newest reservation, the time of reservation, and their party size. This allows us to look up particular information about a customer in case someone was confused on when their reservation was. This simply allows us to look it up. The next query is displaying the item name, customer first name, customer last name, ordered by customer, and pretty much going in again looking for the customer name. That's the keyword we're looking for, and this allows us to see what each customer has ordered. The next query, we are displaying the item ID, item name, and item count of items that are running low. This is a good way for us to keep track of inventory and know when we must order more items. The second execution, we actually just decided we were going to have what we have over 500 servings of, that we know that we won't have to order anything in the I don't know, short time. And then the third execution, we actually have an in-between 20 and 50, which is in danger of running low, that we don't necessarily need to order right now, but in the future we will have to. Our next query is displaying the employee ID, employee first name, employee last name, and schedule date of employees that can serve a reservation on June 5th. As we can see that Eric is the only employee that is working that day that we have in our database, so he would be in charge of that at that time, so he'd be in charge of that reservation. Our execution 2, we just changed the date to May 5th, and we actually have 3 employees working at that time, so any one of these employees could take their reservation. And then we change it to January, and Brian is the only one that is able to take that reservation. Alright, our next query is displaying the item ID, item name, item cost, item count for items on the dessert menu ordered by item name. This is just pretty much displaying all the items on a menu and their cost and count. And we do that for entrees and also alcoholic beverages.
So here are our stored procedures. Our first one is daily items, which generates all the items for a specific date. We've done one for January 5th, 2013, which generates Bud Light, Chicken White, Child Spaghetti, etc. And our second one is generate bill, which generates the customer's bill. It calculates the customer's total and displays each item, as well as the quantity and the price for that each item.
Here we have our trigger. This trigger that we created here was to update the schedule. So an employee has a time in on the schedule, what time they're supposed to be there, and the time out is just an estimated time of when they're going to be done. Now, in reality, this can vary greatly, so they might not clock in at the time they're supposed to, and they might not clock out at the time they're supposed to. So this trigger is to update their time in and time out to reflect what it actually was. And if they clocked in before the time they were supposed to be there, it will update the time and also say how early they were, and if they were late, then it'll say how late they were. We had a little bit of trouble with this getting it to convert to hours and minutes, and yeah, that's it for this trigger. Overall, the project in its entirety went very smooth. We had flexible schedules and were able to get together when we needed to. We evenly distributed the majority of all the work and came up to unanimous decisions with anything we were going to insert and change. For the cons, though, we had some trouble with Oracle sometimes with the syntax, and also with stored procedures and the triggers. Trigger mainly was what I'd say was a big bottleneck in this milestone 4 here. The table creation and data insertion went very smoothly, but when we went to manipulate data, sometimes that's where we ran into problems.
And that's about it. Thank you.
Going back, we would probably be able to do the first couple milestones much easier now that we've completed this to its entirety.